Assalamualaikum warahmatullahi wabarakatuh. Introduce myself. My name is Eka Dina. I'm from International Electrical Engineering. I'm here to the basic practicum of digital engineering in the year 2021. Here I will explain the big tasks of this practicum, namely shift register 14 segments. Shift register is one of the functional devices that are widely used in digital systems. The register is basically a collection of DTFF IC connected in series, so that each bit stored in the key output is shifted to the next flip-flop. The way it works is by shifting one bit of data to the left or right for every given clock period. While the 14 segment is a form of development of the 7 segments, where in these 14 segments, the letters displayed are more complete and more detailed. Okay, in this series, what I use the first 14 segments common cathode and get push button ICTTFF LED and logic state not gate and then or gate and then resistor. Next, here I will explain about the truth table. The truth table of this big task first. Here there is a display, namely letters and numbers, which will later be displayed in 14 segments. We will present practicum 20 to 1, and then here there is decimal, which is the location to store the display. For example, here P will be stored at bit 0 or binary 0. Then here there is input, which is the input that we will enter to bring up each letter or number in the 14 segments. Then finally there is an output 14 segment, which is will be used to assemble the circuit. To convert from this display to 14 segments output, I use an illustration image in Corel Draw to make it easy to read which segments will turn on. For example, here we will display the letter P, then the segment that will turn on is the color I give. So to display the letter P, the light is on and the truth table is written with the number the number 1, only the letters A, A, B, E, F, 4, and the table A, B, E, F, 4, and 8. Okay. Then we write the segment that is not with us 0, 0, D, 1, 2, 3, 5, 6, and 7. Likewise with the other letters. After the 14 segments outputs have been filled, the next step we will convert to the table into key map. To convert it, we enter it into the key map table for times 4. This is for the first one in segment A, we enter it into key map A. Once entered, to group like this. Use the formula 2 to the power of n. That is like in this picture, where the only thing that must be grouped or boxed is 4, thus with a value of 1. Okay. Then the way to determine the key map formula is that in this green box, it is located at A accent and B accent, also D accent. The formula obtained is accent times B accent times C accent, and to connect to other box in the formula, a plus 6 is given place. In the letter A, obtain a formula like this: A accent times B accent times C accent plus B plus times C accent times D accent plus A times C accent times D plus A times B accent times C plus A times C times D accent plus B accent times C times D accent. Okay, in the letter A, obtain a formula like this. For the others, the output of segment B, C, D, and 1 until 8 are the same way as we determine the output of segment A. Next, we continue by assembling the formula that has been obtained from key map using logic gates. Okay. On the left of these 14 segments, I use the output labels A, B, C, D, E, F, and 1, 2, 3, 4, 5, 6, and 8 to make it easier and neater in assembling them. For output A itself, here we obtain the formula, namely for output A itself, here we obtain the formula, namely A accent B times B accent times C accent plus B times C accent times D accent plus A times C accent times D plus A times B accent times C, and then plus A times C times D accent plus B accent times C times D accent. For A accent times B accent times C accent use AND gets because it use transitions like in this picture. Then add to the next one also using AND get, but to connect the two AND OR get is used, and so on until the last output is output 8 the same. Let's just try to see the result that we have compiled earlier. For bit 0 displayed on the 14 segment is the letter P like this. Okay. Like this P, and then for bit 1 will display the letter R. Bit 1 the letter R. Okay. To perform the simulation, we use a push button, namely by clicking the top push button into a closed state. Nah, then click the bottom push button once the LED that lights up is T1. Then if you click on the bottom push button, uh, the bottom push button again, the next LED will light up. Right here it is already on bit 1. Bit 1, and this shows the letter R. The letter R. Then for the second bit that appears is the letter A. Bit 2, the letter A. The next step is the same as this if we give the value to the shift triangle according to this decimal. What appears is the letters that have been stored, namely on the display. We try again on bit on bit 12. Okay, 12. Bit 12 is 2. Here it is already on bit 12, which appears here is the number 2. Maybe that's all I can say. Thank you for your attention. Sorry if there are many mistakes in the presentation of this great text. That's all from me, Eka Dina. Wassalamualaikum warahmatullahi wabarakatuh.